Alright guys and gals, it is I, Coach Goo, back again with another fun-filled, action-packed, flipped geometry classroom video. And today the topic is gonna be arc length and sector area notes. This one should be pretty quick here. I know you like the sound of that one. Alright, so arc length and sector area. First we need to go over some definitions so we understand what's going on here. So let's start with circumference. The circumference is the distance around a circle. It's the distance around. Okay, so my sub changed my pen size. Okay, there we go. Gotta have the big pen size, you feel me? All right, area of a circle, the amount of space occupied in the interior of a circle. That's the area of a circle. You know how much space is inside of that. All right, now for the definitions relating to arc length. So an arc is a portion of the circumference of a circle. So if the circumference is the whole, outside of the circle, the arc would be only part of it, just like that. Bam! All right, next, arc length. Now get this, this may be hard to believe, but arc length is the length of an arc. I should say N, but arc length is the length of an arc. I know, it's kind of crazy, but that's how it is. That's how it is. All right, next. Arc measure. The arc measure is the degree measure of an arc, and it is equal to the central angle that intercepts the arc. You can see in our picture right here, look at this picture over here. The central angle, that's not the highlighter. Central angle right here is pointing to this middle section, and that is equal to this arc length right here. Okay. Next, a sector area. The sector area is a piece of the area of a circle. So instead of giving you the whole area, look at our picture, the sector area is just this shaded section of the circle. It's only part of the area of a circle. And lastly, we have central angle, which is an angle formed at the center of a circle. You can see in our picture, it is right here, their central angle, and then look, it's this angle right there. All right, and then a note at the bottom, a circle is 360 degrees. In case you didn't know that, a circle is 360 degrees all the way around. All right, so take a look at this. We've got formulas to find arc length, and we've got formula to find sector area. Then we have a bunch of proportions that would help me find maybe some other things that I need. But let's just take a look at how we use these formulas here. So look at the first example on the left side. Find the length of arc AB. So let me just highlight where arc AB is. That's from here all the way to here. Okay, I need to find the length of that. So now take a look at my formula for arc length right here. Arc length equals 2 pi r theta over 360. So arc length equals, so I'm going to plug in everything that I know. 2 pi, what is r here? R on this picture is 10. So I'm going to put 10. It's the radius. And then what is theta? Theta is the degrees. So the degrees right here is 120. You can see right there. So 120. And the rest of the formula says over 360. So 3 over 360. So I'm going to put all that into the calculator, yes, with the pi. So I'm going to type 2 pi times 10 times 120 divided by 360. And that gives me about 20.9. And what are my units here? Centimeters. Do not forget the centimeters. There we go. 20.9 centimeters. All right, now check the next one out. This one says find the area of the shaded region. So don't be fooled. They want all of this. Now, let's take a look at the formula for sector area, which is right here. Sector area equals pi r squared theta over 360. So now let's see how we're going to find all our values here. So we got pi, we know that. What is the radius on this picture? It is 6. You can see that is right here, 6. So I'm going to put in 6 squared because that's my formula. Then theta. What is theta? Now be careful. We want the area of the shaded region, right? So what's the degrees on the shaded region? 100 is the non-shaded region. And how many degrees total are in a circle? 360. So if I want to find the degrees measure on the shaded region, I'm going to take 360 and subtract that 100 that they gave me, which is 260. So my theta here is 260. Okay? And the rest of my formula is over 360. So over 360. And I'm going to put this just like it is into the calculator. So I'm going to type pi times 6 squared times 260. Then divided by 360. And my answer, the area, is about 81.7. And what are my units for area? Centimeters squared. Centimeters squared. And that is how you use these formulas to find the arc length and sector area. Real quick, let's just say we wanted my answers in terms of pi. Now, let's just refresh, how would I do that? So for this first answer over here, you can see the formula that we had is 2 pi times 10 times 120 over 360. If I wanted to leave it in terms of pi, what I would do is, in the calculator, what are all my numbers here? It's 2 times 10 times 120, 2 times 10 times 120, divided by 360. Notice how I didn't include the pi in my calculations in the calculator. My answer is about 6.7. But then when I write my answer that I got in the calculator, I'm going to put the pi back in. And I put the units. So 6.7 pi centimeters. Because watch, if I type in 6.7 pi in the calculator, wow, that's about my answer that I had before. 6.7 pi centimeters. And then, same thing for this area one. We're going to put everything in the calculator except the pi. So 6 squared times 260 divided by 360. My answer will be 26. But when I write my answer, I'm going to put the pi back in. So 26 pi centimeters squared. So that's how we put our answers in pi form. You need to know both. All right, guys. So that's going to conclude these notes. Pretty short, right? So I will see you in the next one. Peace.